this control line, you can see I'm highlighting here, input sub or add. Add is negated. Means if I give a voltage input here, it will perform subtraction. If I give 0 here, I mean ground it, then it will perform addition. Okay. So I call it a control line.
Ma'am, please repeat.
Yes. Look at this particular terminal. So this is basically a terminal, means it does not do anything here, just for labeling it. So this is a control line. Okay, control line means this single circuit should be able to perform both subtraction and addition for us using this IC. Okay. Now, how is that possible? So there are two states of this control line, 0 and 1, right? So we will see that if I input a 1, it will perform subtraction. If I am giving 0, that is low voltage, I'm going to get addition. Okay. So now you see, you know the logic, I believe you remember, I'm just repeating it. For subtraction, we perform A1 minus, sorry, not A1, A minus B. Both are 4-bit 4-bit. Now, as I'm using an adder, this minus B has to be complemented, right? Like B, the magnitude of B has to be complemented to get minus B. And we'll be using 2's complement form for that. So basically A plus 2's complement of B. Now to get the 2's complement of B, okay, let me write that too. It's like A plus 2's complement of B. So this can be written as A plus 1's complement of B plus 1, right? 1 in binary. So like this. Now you see, this is basically a simple addition operation which can be performed by an adder, right? So we have an adder already. So you have to think like that. These 4 inputs for A will have A as it is. For B, however, it needs a complement of B, right? You see this 1's complement of B. So all the B pins are gonna have the complement of B. And we are going to also add a 1. So for that 1 would be provided as the input carry for position 1. So we know, right, that if I have A1, I'm writing from MSB. So A4, A3, A2, A1. The second operand would be B4, B3, B2, and B1. Okay. And then at the lowest bit position, the carry input is C0, right? In an adder, the lowest bit position carry is C0. So that is here, C0. Correct. Now what we are doing? Say we have negated this, as I was telling that we need a 1's complement of B here. So in the pins meant for B, I'm providing complement of B, right? And we are also like having A as it is. But here we need additional 1 to get the 2's complement of B. So that 1 I am going to provide as C0. Okay. So if I provide C0 as 1, effectively what it becomes is like just writing in another line. Okay? Effectively, what it becomes is like 0, 0, 0, 1. So effectively, it reduces to this. Understood? So this will, in this way, it will give us a subtraction operation. So we'll get in the end A minus B in 2's complement. Of which we also ignore the C4. In this case, we ignore the C4. C4 is ignored. The output carry is ignored. So if this is the case, you can understand. So if I have a control line over here, if you now just focus on the circuit organization. Okay. How it is like, this is connected to each of the XOR gates. Now you just recollect why these XOR gates were for. The XOR gates were for complementing B, right? XOR was for complementing the bits. Okay, and how it can do so? Because one XOR bit position, say BI, would give us the complement of that bit position, right? That we saw from the XOR table. So see, of course, for one of the pins in this XOR gate, we must use 1. So we have this control line that is connected to this 1, 4, 9 and 12 pin. That is one input for each XOR position, each bit position, and this C0 is also connected to this control line. Correct? Now if I have connected to power, so this will be 1 each of these pins, as well as C0 will also be 1, because that is connected to this power line, this control line. So if it happens so, all the XOR outputs becomes complement of B for the same reason I explained, for this reason. Also we get in the at the same time C0 as 1. That is useful for getting the 2's complement of B. Okay, so this is how I organize this particular circuit.
Ma'am, the only difference between the adder subtractor and full subtractor is that the control line. In the case of subtractor, we will have to always keep it 1, whereas in the case of adder subtractor, we can switch. Like 1, if we will keep it 1, it will execute subtraction, but when we will keep it 0, it will execute addition, right?
Exactly. That is it.
So, ma'am, the only difference will be that control. If we will keep it permanently 1, then it will be a complete subtractor. But when we will add control to it, like then we will be creating an adder subtractor, right?
Yes, absolutely. Yeah.
Yeah,
perfect. That is a perfect summary of what I was saying so far. Okay, so let's simulate. Let's see the input. You see 1 1 1 1 we have, right? Here 15, and we have here this is 1 and this is 1 and this is 0 and 0. So this is basically for B we have 3 and this is 15. So 15 minus 3 we should get 12, and 12 from this 4 bits. From bits we'll ignore this bit. So as this is high voltage right now, so let's see. Correct. This is 8 plus 4, 12. And we ignore this bit. Okay, so it's giving us the correct output for subtraction. And let's just do the addition. I'll just change it to some ground. So in this way, I make the control line 0 by connecting it to ground. Okay, let's save it and execute. So you see this small squares. These blue squares are 0, denoting 0 state. Red square are denoting 1 state. So you can see all the XOR inputs are going 0 and C0 is also 0. So as your friend explained, it should perform addition. And what is 15 plus 3? 18. So am I getting the correct answer? So this is the 0, 1, 2, 3, 4, fourth bit. So this is 16 plus 2, 18. This time I'm not ignoring D5, okay? Only for subtraction I'll be ignoring C4 because we are using 2's complement, and you can find it in your theory book, all these explanations. So we are getting correct response for addition also. Okay? So this is the simulation. If you want a screenshot, please take.
Ma'am, now it is performing addition, that's right so?
Yes, yes.
Ma'am, from B4 to B1, it is 0011 means 15 plus 3, and when it performs subtraction, then from B4 it gets 1100 means minus 3.
Yes. 1100 and C0 will be 1.
Okay, ma'am.
You want to see subtraction again?
Yes, ma'am.
Okay. Look at this. As you said, it should be, this is complement of B. 0011, that 3 has become 1100 now, complemented. Okay? And C0 is coming as high, this red dot. So that means it's 1. So this is 1 plus complement of B plus all the A bits. So
1100 is ma'am minus 3.
yes, minus 3 in 1's complement form. Just keep that in.
Okay.
Yeah.
এদিকে এত ভয়, এদিকে মাস্ক খুলছে, মুখে বারবার হাত দিচ্ছে। মুখে হাত দিনি তো, বারবার মুখে হাত দিচ্ছে, এমনি করে মুখটাকে মুখে এইখানেই হাত দিচ্ছে। মাস্কের উপর হাত দিতে কি সমস্যা? দিয়েছে বলে গাড়িতে করছে। না, মাস্কের উপরও হাত সমস্যা আছে। এই ফেসে হাত দিতে মানা করছে। হে মা, তুই হলে গিয়ে বারবার স্যানিটাইজ করেছিস হাত? হ্যাঁ। আরে হলে
I think 10 minutes to go till the class ends. So you could submit, all of you, the assignment. I mean today's task. What SLC ma'am gave.
Yes, ma'am.
Ma'am, the previous assignment though.
Ma'am, that full adder and parallel adder though.
Yes, that one only.
Okay, ma'am, done.
Yes, ma'am. Submitted.
Okay, thank you.
Yes, thank you, ma'am.
Shall
So we can leave then, ma'am.
I stop the simulation? Everyone,
Yes, ma'am.
yeah.
Ma'am, can we leave?
Yes.
Hello, ma'am.
Yes, I'm listening.
Instead of Ma'am, instead of ground or what should I say, power, can we
Yeah.
use logic probe? Because ma'am, because in the case of ground and power, we need to change it again and again. But ma'am, when I use logic probe, we can just change it by a simple click, like zero
Yes.
one. So
You
can
can.
we use it?
I'm saying that you can. If you see, why my intention to show you like this hard way, is to make you understand that the difference, it's not always a one click. Okay, because if I do not have
Yes, ma'am, I got it.
yeah, so if you know this and you know that as well, you can choose any one of it. As long as you can explain me what is happening, you will get points for that. Okay, so there is no such
Okay,
problem.
ma'am.
You do it your way, but you should be able to explain. That's it.
Thank you, ma'am. Yeah, ma'am.
Okay, no problem.
যা সমস্যা তো নিজের মনে মনে ঘন্টা বাবাকে বল, আমাকে বলতে হবে না। যত আমি আর কিছু তো পারবো না দায়িত্ব নিতে আর। যত নিচে তত আমাকে এসে গর্তে ঢুকিয়ে দিচ্ছে, গর্তে ঢুকিয়ে দিচ্ছে একবারে। কি রে বাবা?
So if you have all submitted that assignment, then you may leave, I guess. And one more thing,
কিচ্ছু নাই ঘরে।
whatever your queries are, will be discussed. Come again? Come again? Yes, that link is open. That would close at 2 o'clock. So,
Okay.
yeah. So whatever your queries are regarding VHDL or any other hardware circuits, we will discuss them in the extra classes we are given. Okay. And we'll also discuss your assignments, whatever you have submitted or you're going to submit. So we'll see that if there is any problem in that, and we'll discuss that.